Hello. Testing. Testing. Sammy, would you? Okay, but Samuel, would you speak? We can test you. Okay, we're just gonna wait for distributed here. Gang assemble. See, reminds me of Power Rangers assemble. Okay. So should we get Evan up on stage? Just by the way, Samuel, you're muted at least from my perspective. Evan,
Hey guys,
you're loud and clear.
super.
Anybody else? Evan, is there anybody else we should assemble onto the call here? Like Adam W?
Yeah, distributed has already pinged the guys, so we should be expecting two more.
Okay, great. Oh, we're gonna get the whole hangout. Is Demo Dillo coming up?
Should be. There you go.
Okay. They
Yeah.
they could just be random people, like so I have to I'm like the bouncer,
Yeah, for sure.
Makes sense.
Okay. Got all the Templar community in the hood. Hey Adam, welcome to the stage. People file in. We're already a minute over and distributed is still muted. So I don't know what's going on there. He says he's just jumped out of a plane. Samuel? Mic test from distributed, please, because I believe you're going to, unless you want me to do the whole show for you. But I feel like I'm not totally prepared. So this was supposed to be delayed or canceled, but Samuel canceled all of his flights. So he's a man that has burned cash in order to be here, guys. And we are all very thankful, yes. Samuel? Nothing coming through just yet from Samuel's side. Well, he sorts that out. We've got Oria. Is this the team that I don't know about, Samuel? Are these people coming from within Inside Covenant Labs?
Yeah.
People can hear me.
We-
People can hear me correctly. People can hear me.
Yes.
Yeah. We're perfect. It's all distributed here. I mean, is there an option here where distributed just drops, goes into the audience, and we just talk about distributed training without him? I think we could handle it. All right. Well, okay. I want to, while people are figuring that out, Can you all see my screen?
Yep.
So I was just building something today with Crux, which is it's effectively a Ridges it's a Ridges clone, but it's a general Ridges clone. So if people want to build, it's like a template for building open source innovation style subnets, and basically like what you need in order to make something like this work well is you need to have a sort of like an agent class that accepts entry points within inside of a Docker container, and then the ability to run those agents inside of Docker container where we can still port tools to that agent, like some random function or an LLM. That like this is how Ridges works, right? So they build an agent. That agent exposes entry points. They solve sweep bench problems, and they have access to tools that then connect to the host, and the host makes queries. So, anyways, I was just doing building this today, and so while we're waiting for Samuel, I just thought I would share this with the community. I'm going to post it into the chat for people that want to build off of this template. I called it SN1 because we're actually revamping SN1 right now. It's going to be very cool. So if people want to build off that template, building subnets, like if you're interested about how you could do sort of like Docker, Dockerized agents that you pull from the chain, and then run the agents within inside of a container, and then those agents are able to access the web and potentially use like SN13 or other things, other types of tools on BitTensor, while you can maintain that containerized on your validator. So yeah, I just want to throw that out right there. It's not like the perfect product. It's it's all built in a day, but I thought that I really think that this structure has become really efficient in BitTensor. So please, yeah, take a look at this and see if it makes sense for people, and maybe we can turn it into a new template for BitTensor itself. Okay, Evan. So what's going on here? So where's our main man? Should we just boot him and just nothing is stopping this train?
I mean, we can always start. It's just Sam always gives, the extra the extra power in the chat. Yeah, I guess.
We can't hear you, Samuel. Try to leave and come back. Check your mic setting. Oh wait, something came through. Nothing came through. I think you're going to have to do it, Evan, without him, and I'm just going to have to be the additional energy. Not even 1/10 of what Samuel can bring, but unless he gets his mic, perhaps Marvin can give him a hand.
All right. I have to go completely rogue here. That wasn't planned. Okay.
Maybe he can just try his phone. Let's give him one more second. It is Samuel. It's a big deal. It's a big deal, and he's just missed. I'm she's sorry. I even suggested. Of course, we're going to wait for him. Distributed. We want Sam. Someone give him a mic. Oh my gosh! Like, buy a new laptop, Samuel. Are we going to have to jump to the TJFT channel? Poor guy. Turn it off and turn it back on. Blow up your computer and then piece it back together. Well, nobody's leaving the call, so everyone's stoked here. So this is great. We're just chilling. All right. Well, in the meantime, I suppose I will open the slides. Evan, do you want to see if you can share your screen and open the slides from your perspective?
All right. Yeah. Let's say that. Why not? One moment. How about that?
It's
Can you see
something
that?
changed. Well, not yet. Just give it a minute. Nope. Okay. Well, I just happen to have the
Through?
slides. Not yet.
Mm.
This tends to happen like when we have multiple people joining from multiple continents. So it's okay. So I think that I will perhaps have to do this for you guys. Samuel's on his phone now. Are you coming through? So Evan, no one can see. Try to share again.
Mm-hmm.
Is it a PDF? Is it Keynote?
It's like a Google Slides kind of thing.
Well, with
Just
all
setting that.
of these errors, the audience just keeps on going up and up. So no, it's still not coming through. I think that we should just drive this through as a conversation. If we can't do that, so what I'll do is I'll just post the images in the chat, and we'll stitch it together.
I can try it on my side as well to see whether I can share the slides or not.
Yeah, please.
Let's go. Let's go.
Someone asked me to recite my favorite Terence McKenna lecture. Permaculture. I don't know enough about Terence McKenna to be able to recite lectures, and I mean his lectures are pretty wordy. Have you ever seen the one where he's up on stage rapping to a didgeridoo? You got to find that one. Okay, it's coming through. Okay, so we got the slides.
Yeah, perfect. So can you see it?
Yeah. Yes, it's good. It's good. It's coming through.
Perfect.
Yeah. We're great. So make it full screen. Amazing. Okay.
All right. How do you want to do that? Shall we start with the prologue and continue on the technical details, or?
Hello,
It's up
can
to
you
you.
hear me now?
Yes,
you
we
go.
can.
Fuck yes. Sorry, guys. Like seriously, like yeah, the ritual guys are being tough for me. Apologies for the mishap. So let's get this show going. So thanks everyone for joining us. I think this is for us. This is a very profound moment to share with the community both how we think about BitTensor and how we see us growing forward. Because everyone's like, oh no, he's bought another subnet, greedy subnet owner. But for us, it's a strategic imperative because we believe that so we believe that it's important to be able to have this pun intended holy trinity working. So can we go over to the next slide? Okay, so yeah, agenda, we're going to do a little prologue, set a bit of lore, then dive into, the meat of it. Like, what is Templar doing? What is Grail doing? What is Basilica doing? And what does the whole picture look like? And how do we think it helps us move the ecosystem forward? Next slide. So again, this to me is it's very profound because you need to think about why do we do this here? Now, to understand where this comes from, is to understand at least my why of BitTensor, which I then enforce on everyone that works with us. It's really BitTensor is prophecy. So if you look at things as they emerge, you can look at imagine a graph. You have a y-axis and you have an x-axis. The y-axis represents a theme, and the x-axis represents an iteration of the theme. Stay with me. So, what is take for example the cars? How do we get cars? There were multiple iterations of the theme of combustion engine, locomotive, the Wright brothers. They all came together to produce modern transportation. So even though individually those things failed, eventually the theme succeeded. So the moral of the story is themes can fail, iterations can fail, but themes ultimately succeed. Now, what does this have to do with BitTensor? Go back to the story of the internet. The internet's promise, the internet, we can argue it's failed, or the original idea of the internet has failed, but it still endures. But the theme of freedom, of self-sovereignty, is still worth fighting for, and it will not fail. Now, we see the internet was an iteration of it. It's been perverted. Blockchains were an iteration of it, and for the large part of it, it's been perverted. We believe that BitTensor is or can be that iteration that pushes things forward. And to us, subnets are not just, obviously, subnets are meant to be efficient entities that, draw revenue, but I think it's a lot bigger than that. They're meant to be tools by which the prophecy of BitTensor is manifested. So that's everything we do. It's not like, because if you're just going to take a SaaS or do something for Web 2, then you will never do it better than Web 2, because it would just be a cheap port. So everything, all our subnets and everything we do is that, okay, how do we magnify, how do we use this this chaotic jungle of BitTensor to produce epiphenomenal products? So that's law, and that's what we need. So we present three manifestations of prophecy: Templar, Braille, and Basilica. Next slide. So this is my so Templar is a pre-training run. Started from pre-training protocol. Started from very humble beginnings, and now we are pushing the Pareto frontier of what is possible with pre-training. We are currently training a 70 billion parameter model, and it's the biggest one out there. Like, a lot of people have even given up on pre-training. On to the next slide. Yeah, so I added this 5 minutes ago, and I think that's why, because everyone will tell you pre-training is dead. And I think this is the biggest piece of psyops. Because people argue that, we've pushed base models as quick as possible. Meta's gonna release those base models. China is gonna release those base models, but anyone that believes Mark Zuckerberg or China, that they don't even let people use the internet, are going to give us tools of liberation as an idiot. But they seem to be pushing this narrative that, okay, we already have base models, but Templar continues to prove that this is a fallacy. The ability to create base models will be so much more important. And we can already see things happening. Look at Meta. They're not going to release Llama models anymore. Do you know how much research and development Llama models enabled? DeepSeek probably will stop releasing once they have their IPO, and you just generally can't depend on China. And you see projects like Ridges, I think Ridges is based on GLM4. But what happens when the GLM guys stop releasing open weights? If we do not keep persevering on being able to compress the library of Alexandria into a weight matrix, we're pretty much screwed, because eventually these guys turn the tap off. So we can look at these open weight policies, and even Hugging Face, all of them, they're in bed. They're all co-opted. It's just a go-to-market. We need to always be able to do this, and this is the hardest skill to follow. And at Templar, we haven't mastered it, but I look around and we are at the Pareto frontier of pushing research, development of what these models can be. On to the next slide. Okay, yeah, so this is a 70 billion parameter model. I mean, it's not perfect yet, and Joel, Adam can attest to how much stuff keeps breaking. But we're okay with stuff being broken. Like we start, we push, and we make multiple quick iterations towards getting that final product out there. So this is probably going to run for for a bit until it's kind of working, but right now miners are upset they don't get checkpoints as much, and just minor things we need to do. But once we get this stable, we push efficiency, and right now we're at the model size where we can start to take a decision. Do we want to build a software based model? Because as you remember, one of the things one of my missions is to put an end-to-end train model on BitTensor on the global stage. So I think we're getting quite close to that. Next slide, please. Okay, now again, so people are always going to leverage your insecurities, and sometimes you leverage your insecurities about them yourself, and you work against yourself. But when I started Templar in November, we had copied Demo's code, Noose's code, and every time we spoke to people, like, oh yeah, you copied your code, but it was okay because we were just getting our feet wet. So we gave the world permissionless training, and now we've given the world the state of the art for distributed learning training optimizers, which is a massive deal. We think stuff like this is what puts BitTensor on the global stage, because you see, it's what puts BitTensor on the global stage. So Amir, because again, these guys have gone far above my pay grade. Amir, do you want to come on stage to discuss, at least at the high level, because most of these people get bored, on the work you guys did with Sparse Loco?
Yeah, for sure. So yeah, we introduced the novel optimizer, Sparse Loco. It uses Tokay compression and 2-bit quantization to achieve like more than 99% comms compression, while actually improving performance. So we actually outperform Prime and Google Diloco and so on. So yeah, please check out our paper. The title is here.
As expected, the crowd is getting a bit bored. But this kind of stuff is very, very important for BitTensor, because you see, it puts us in the right rooms, and hopefully this paper gets us into the right conferences, because we know we are legitimate. But I will always go back to
Wait. Why did you say that the crowd is getting bored? There's absolutely nothing boring about this at all. Can I grill
FX Mars? Remind me to ban him. Okay, cool. You can grill Amir. Don't grill me. I don't know shit about this. Grill Amir.
Yeah. So I mean, we've been following this for a long time, right? We've been trying to do decentralized training on BitTensor for a very, very long time, number of years now, and it seemed to people in the industry that it was just simply impossible. Like the frontier models, the foundation models that are being trained by centralized labs were going up into the hundreds of billions of parameters, and in order to do the all reduce step to actually merge the model weights, we would look. It's like what, 400 gigabytes per model, and if you go into 100 different nodes, it's like 4 terabytes per merge, and you have to do hundreds of thousands of merges to hit the number of tokens that you would need to really train a foundation model. So it just, like, a couple of years ago, it was simply impossible. Then out of DeepMind, I believe it was DeepMind, right, that they did DLoco?
Yes, that's right.
And so DeLoco, changes the game somewhat, because with the Nesterov momentum as the outer optimizer, you basically have an inner optimizer. You do a bunch of local steps. And Eugene Belyovsky is like someone that I know had been working on this for years. I met him in 2019. He was working on this, working on how to do specifically that. DLoco is the latest iteration of research that Eugene has been looking at for years, and basically it's do a bunch of local training and then occasionally merge the weights. And so DLoco out of DeepMind seemed to be the best, and this allowed us to reduce the communication bottleneck substantially, because you don't have to merge every optimization step. You guys took it further by actually adding compression, top K compression, into the merge step, which, if I understand correctly, was like not possible. Like people thought that was not possible because why was that exactly? Amir, can you explain a little bit more? Like, this is where my knowledge of what you guys did breaks down, and why I think it's so significant.
Yeah, so it's not actually trivial how it combines with DLoco, because naively when you combine them, it's awful. But what we found out is you need to completely drop the Nesterov outer momentum and completely replace it with the top K and error feedback. The error feedback buffer. So actually, there were multiple problems. Like, one was they don't combine well, and the other one is you get to have two buffers now, like the Nesterov buffer and error feedback buffer. So like our contributions, like one of them is you don't even need the Nesterov that DLoco actually advocates for. You just need the top K error feedback doing the job of momentum as well for you, and somehow it's doing better in accuracy.
And so why is it called loco? Like, what, DLoco was sparse loco. What exactly is the loco aspect of the name?
I think it's low comms, low communication.
Low communication. And so how low exactly? Like, when there was, I think the result from the paper was quite substantial, like in terms of both the number of communications. So this beats out demo, right? Because you're both compression, right? So you have like massive compression in the gradients, but you also can communicate sparsely, like, or over many steps. Like, does anybody have is there a slide here which shows that comparison?
Yeah, there is, and yeah, we outperform demo and naive combination of demo DLoco and DLoco as well. So, and for the compression rates, like, we send only about 1% of the gradients, and we send them in 2 bits instead of 32 bits. So it's actually like enormous amount of compression.
And so what does this mean for like how much we can scale Templar?
Yeah, so right now we're training a 70B model with this and communicating, I think, in 70 seconds or something. Like, that's crazy numbers comparing to like Prime or other frameworks.
Like, what would be like, what's the communication speed for like the 40 billion run out of Intellect and News Research Psych? Like, how does that stack up in terms of communication speed?
Yeah, so like for I don't have the exact numbers. Like, maybe Joel has the numbers if he's here and he can comment on it. Or even
numbers either.
Okay, well, it doesn't matter. The point is that it's a lot faster. There's a so what question from TP in the chat. And like, just to put it bluntly, without an efficient communication method, you can't train large machine learning models, which means that you can't train state-of-the-art machine learning models, which means that it's insignificant and there's no point of even doing decentralized training in the first place. But if you have the algorithm like these guys have just invented, you can train very large language models across disparate compute. You can do it collectively. We can use all of the compute subnets on BitTensor, like Basilica and Liam, to actually contribute to it. We don't need to be in a single data center. We can actually stitch together an incredibly large model instead of needing to all be underneath one roof. So it is really the linchpin or the keystone to enable decentralized training. And like, it's funny, it's just one slide here. That's why I had to stop. I had to put the brake on here because, for the people listening, like, this is an absolutely massive innovation that puts like the work out of BitTensor really at the forefront of our field, and allows us to be both the largest machine learning models, the most incentivized, the only permissionless, and truly decentralized training runs in the world. So it's really big deal. It's really amazing. I'm so stoked that we're here. But I'm going to back off now and let Samuel continue with his presentation. Apologize.
No, it's still Amir for a couple of ways, but thanks for adding some colors to this. So again, this brings us a lot closer to putting a BitTensor model, state-of-the-art model at the world stage. So we're pretty excited about that. That's the show up. Next slide, please, because I've been told I've sounded too bossy. Yeah, so Amir, do you want to talk through this? Hello? Okay, yeah, so this just goes through the research and the ideation process. We started off with demo. So we started off with demo, and we started off with demo, and we quickly iterated through that. It took, and luckily, because one of the things that BitTensor gives you is hyper experimentation. So because we're built to deploy a lot, and we put our miners through hell, we could actually do a bit of research behind the scenes and deploy stuff into production until they worked. Next slide, please. Okay, so this is timelines, and in the scheme of things, it's pretty crazy because in the space of 8 months or 9 months, we've been able to scale our model from 1.2 to 70, which represents, I think, a 58x in how big we can go. Now, it's not, people are going to ask, like, where does this go? Like, are you just going to keep getting to bigger models? It's not a very easy choice because at 70B, we can cause a lot of damage if we train that model to production, then supervise fine-tune it on gradient and push it to grills or an affine to fine-tune. So to do reinforcement learning and give it intelligence. So it's like we need to take a step now. Is that do we do different architectures? Do we train with more tokens? So that's what we're going to be doing at this stage now. But the next big milestone for Templar is not going to be really about size. It's going to be, okay, can we get this really, really good base model that gets us closer to our goals? Cool. The next slide. Basilica. So Basilica is a compute network, and it's like it's for us. It's like, okay, to train these really, really large models, we need a lot of compute. And we need to be able to natively integrate this compute into our networks because we can do a lot of things like augmenting the consensus mechanism. Then on building, we realized that, okay, there's a lot of things that we develop by way of Templar, by way of grills that are going to go into in a bit, that in their own, they're startups on their own. So we have a choice. Do we stop the work on Templar and try to push that out, or stop the work on Grow and try to push that out? Then we miss the chance of being able to develop these things again. So in this first incarnation, and probably for like the next 2 to 3 months, Basilica is just compute rentals. It's just the sacred, it's just, it will help us. We need to dog food it, give it to miners, give it to Templar miners, give it to them to grill miners, pretty much anyone that wants to help us dog food it. Because the plan for Basilica, next slide, is to build value-added services. Now, this is a hill I'll die on. Selling decentralized compute it's hard. First of all, getting like anyone, like all the decentralized compute networks that have come before us and those that will come after us, fucking salute, guys. This thing is very hard. But when you look at the unit economics of it, it's very hard to return more than you get with a compute network, because you will never, unless you own the supply, you can't be, you can't take in $1 of emission and return 1.2. So for us, that is which is okay as you bootstrap the network, but we believe we should do more. So in the coming months, we're going to be building service layers. We're going to be building services on top of Basilica, which help provide this. So we can talk about Grail. We'll come back to Grail, but this is where we see it would really drive value back to token holders. Is not just because you can make revenue go up, but if you're selling a discounted service, that it doesn't even have to be as good as the full service. So that will give but that has that's actually quite perverted, because it has the effect of saying, oh, they have revenue, but it's never ever going to. I think it's going to be very hard to surpass minor emissions and stuff like that. So the only and I think the only way to do that is value added services. So I will talk about one we might build to show the effects of combining research and a compute substrate. Cool. Yep. Next. Yeah. So this is Basilica's deployment. So it's been very rough. Miners are going to be miners, but we want to keep it permissionless, and we have to go through the steps for it. So currently we are solidifying the validation. Some of the assumptions we made were wrong. Miners will look at your verification system and literally troll it and debug you. But we have Evan working tirelessly on that. Evan, do you want to give us your 2 cents on how much you've aged and where you see this going?
Yeah, sure. Basilica. As you said, we are. The fundamental problem that Basilica is solving from the technical perspective is to be the most highly available compute network, even though it's decentralized and distributed in the way it is. And it has been through blood and tears, because everything that could have been exploited has been exploited, and probably. And this is helping us. This is helping us a lot because at the end of the day we want to build something that is anti-fragile. So the fact that it is breaking now is making sure that it won't break later. We're just going through that. And Sam, as you said, the roadmap is not to be just a compute layer, but to add more highly available and more valuable services on top of that. And we have lots to develop there. And this is where the innovation will be after we finalize the production readiness.
Cool. Can I please have the next slides? Cool. Okay, so Grail. Grail is our latest subnet, and it's something that it's like so for a long time we thought just pre-training mattered, because before, the compute budget for pre-training was like 98%, and push training was just a little trick you did at the end to give your models some bells and whistles. Grok 4 changed this in our minds, because for the first time, the compute budgets for pre-training and post-training was exactly the same. So, and why we look at the compute budgets is that the core reason for decentralized training is that the compute budget is so big that one person can't come up with it. So if we can divide this work amongst the many, then maybe we can democratize access to that. But it's rapidly showing that RL on large models can push the frontier of intelligence. So we started working on that. I'd like to invite Irfan. Irfan, can you come give us a few words, because so we hired him because he lives and breathes. When you're looking for, what I like about most of the team is that almost everyone we hired has been doing this or doing kind of adjacent work before they found this. So it's like, wow, you guys are doing this. I want to, happy to jump on ship. So, Irfan, do you want to give a couple of words on the work we're doing and where you see this going?
Of course. Thanks for inviting me. So on the Grail, what we trying to achieve right now is that, in the beginning, we most likely gonna focus on like singleton reinforcement learning and get that done properly. Actually, let's go to the next slide because we talk about it a little bit here. So like singleton reinforcement is like one of the things that actually like industry really cares about right now, and it's, coming with RL fine tuning is something that is pretty important. But like eventually we want to go for multi-turn reinforcement, so enable for our agents to reason without any limit, and they can get better over time. But like after that, what we have in mind is actually we want to find a way to incentivize people to give us like reinforcement learning environments. Because right now, like after we get to the multi-turn reinforcement learning, what's gonna happen is that we want to be able to like train really good models that can surpass other state-of-the-art models like in the industry. So that multi-turn kind of reinforcement learning with proper environments gonna help us achieve that. Yeah, like
Cool.
Yeah.
Cool. Yeah, exactly. So it's like, again, it's still the same. It's not it's not getting a subnet for subnet's sake. It's looking at, okay, given where we are, does it make sense? Like, how do we keep pushing? How do we deliver on our original goal of building a state-of-the-art foundation model? And RL has become a very big part of the puzzle. So we'll be doing that. But what is very interesting is in developing this, so the process of at least distributed RL involves generating reasoning traces or rollouts so that a trainer can train on it. Now, the question in BitTensor always comes to, how do we verify that the miners are not fucking with us? So Const and I got round with Umoral for a week or so, and we developed an algorithm called Grail, which is in itself its own startup. So what Grail allows us to do is to compare, to sample indexes from the model's hidden states, and we can prove that miners trained on a particular model, or miners generated a rollout on a particular model. Is super quick. I think Prime had some interesting work called Toplock, which is which did something similar. But our Grill is so much faster, so much cheaper, and it's to our knowledge, it can detect if a miner is trained on that model. Now, why is this important? We start to see how we take work from different subnets and apply it to Basilica. Because if tomorrow we want to do verifiable inference, it's a massive problem that no one is tackling. So take, for example, we all use Claude. But all of a sudden, you notice Claude is not acting, it's not Opus anymore. It's not even Sonnet 4. So protocols like Grill can help us verify that, look, miners are running the right model. Your provider hasn't switched them. Because the providers do this all the time. It might not even be as much as like Sonnet 4. It might just be like, okay, let's run this in 4 bits because it's cheaper to serve, or let's downgrade something. So this is something we're actively looking to develop. And it's the kind of product we'd love to push out on Grill. Next, please. Thank you. Cool. So this is the Grill development timeline. So for Grill, we're going to roll it out because we do have some research, but we need Irfan and a couple of other people to really beat it. We don't want to take claims that are half-baked to the world. So in our first iteration of Grill, it's not going to have the RL training yet. It's just going to be, okay, miners, can you break this stuff? Can we prove that Grill really is state of the art when it comes to verifiable inference? And we've built a startup with that already. Then after that, we start to do the really interesting stuff. That, okay, how do we put this model out? How do we improve this model? So, assuming in the ideal state, we take a Templar model and put it on Grill and try to improve that, then move it up to Affine to move it up to Affine for mine, because what this will do is we can really, really push it on different environments, different rollouts. But with Affine's environments, we can then put it on there and see how miners really, really push it to edge out all the other models. So that's the aspiration for where that comes from. Next, please. Okay, so now this is my personal rant. We need to escape local minimas, and given BitTensor itself and even life, it's made us creatures of PvP. We need to reach escape velocity, and we can't do this if we keep gaming emissions. Keep and all the other tricks we play. And I'm also convinced that there's no way to do this that is sustainable by blindly copying existing businesses, because it's also hard. But I just think that a lot of times when you try to compete, copy existing businesses, you will run subsidized, and it becomes a lot harder to get that exponential ROI, because you're either overpaying or you're over subsidizing, and those guys can subsidize far more than us. So is an understanding, okay, what point do we get to? Because if you look at the people who are going against, the market caps are more than the whole of their market caps are multiples of BitTensor. Their industries are multiple of BitTensor. So we need to be smarter. We think adequate investment in research is tantamount to emergence, is tantamount to building these moats that help us leapfrog centralized counterparts. Because again, we don't care about an AWS of Web3. We don't care about, because AWS of Web3 is only ever going to be useful to Web3. You cannot become AWS by building AWS stuff. You need to develop new shit, new primitives. And this we have done, literally, this we've done with Grill. We plan to do more. And this gives you the kind of a flavor for the kind of value-added stuff we can do. We plan on doing. There's something really big we're cooking on Templar. If my research team have told me if I talk about it, they will all quit. So I'm just going to give hints. In the next 3 months, it'll be possible to get the. We foresee that we'll be able to run cheaper hardware and get the same amount of flops. And this is a service that will be exponential, because it would mean we can use A100s and still have the same effects as H100s. Then we start to see the multiplier effects that become, okay, these three things have come together to produce a product that is more than any of the individual parts, that is far more than its inputs. So it's stuff we're pretty excited about. Next, please.
Wait, can I predict that what you're going to try to get non-NVIDIA chips onto Grail?
It wouldn't matter if it's non-NVIDIA. Like that's a small goal, and people are already doing it. It's a lot more than that. It's about making chips Superman. It's like, yeah, so it's like literally making an A100 a H100 to have the same effect as an H100. So that means we can just use cheaper computers to build services.
I can add something there actually. So I mean, Grail, one big important part of the Grail is actually inference. And during inference, we can use a lot of different chips, even Mac OS chips or everything like that. So M4, those kind of stuff. So it doesn't matter if it is NVIDIA in the end.
Cisternas, I'm not owning shit with Cons. He's my competitor. I exist to destroy him. Cool. Okay. Yes. Cool. Okay, so that leads us to, so what does this come from? It's so we very shortly will be rebranding to Covenant.ai. It's going to be one architecture with a unified view of capturing the whole intelligence continuum. We do have a website, but unfortunately, I fucked up the domain. I bought Covenant.ai instead of Covenant, so we're trying to get someone to go procure that for us. But yeah, it's pretty exciting direction, and it's just to reiterate that these three subnets do not represent a loss of focus, but more of a broadening of view. They say go as far as you can see. When you get there, you will see further. And we haven't conquered pre-training, but we've done pretty well. And I think Templar is at the forefront of the world, in the world right now. But we see what the next peaks are, and we're very excited to embark on them. Cool. Thank you.
That's it? Wait, you're not announcing any more subnets?
There's 2 more we're working on.
Very cool. So let's go into a couple things. So let's talk about how the subnets are connecting. I'm really interested in this. So at one level you have pre-training. We did a little bit of a pin there about how you guys have like really invented one of the most impressive algorithms for decentralized training. That's ongoing, but that's like a side note. Then we have Basilica. So what is it that you guys are doing on Basilica that is state of the art compared to the other compute subnets on BitTensors? Like what actually sets you guys apart? Like, or how, in from a vision perspective, from an application development perspective, from like a user perspective, like what is it that you want to like? What do you want to attack?
So for us, we want to. It's all about the value-added services. Yeah, how we can do verifiable inference, how we can do, innovate on hardware efficiency that allows us to serve things a lot cheaper. So that's where a lot of the value lies. But getting there, we need to first of all solidify the base, and that's going to take a bit of time. So for the next month or two, it's very likely we don't look much different than a compute rental network because we need to solidify the core. Once we get that core running, then we can build services on top of it. So yeah, it's the quote unquote services that set us apart.
Right. So it's like you guys want to make the compute like incredibly usable and like you said something about how like we have to not reinvent the wheel here. In terms of making AWS, what would it look for like for an application layer on top of decentralized compute?
It would look like it would look like seamless services being able to be deployed, but the kind of research that goes into that verifiable inference, I think Omron is doing as a service, but it hasn't been deployed at scale yet. Or being able to use cheaper compute to unlock the same efficiency, those are global problems. Those are like world star type of problems. So what would that mean? It would mean that we can cut the cost of compute and the cost of services by a massive factor. Now, if you look at things like inference, if we're training, we all pay a massive Jensen tax. We pay a massive NVIDIA tax. If you're not paying that NVIDIA tax if you're not paying it to Jensen, then you're paying it to his cousin. We always pay that tax. So one of the innovations we're working on that's going to come by way of Templar and land on Basilica is the ability to retain the same amount of T-flops, but with far cheaper compute. And we just keep them rolling.
So this ties into the other subnets because you guys want to build like first class miners on Basilica that like plug themselves into Templar, but also Grail. Correct? Like you're actually thinking about like how Basilica like plays a role in providing the computational load for your subnets.
Yes. But I want to make it clear that for us, Templar and Grail are just the first targets because it's easier for us to dog food. But there will be no gatekeeping or whatever. Like Basilica is open to everyone. But for us to develop this kind of like reinforced incentive mechanisms, it's better to do it within the team. But once we've perfected that, we're talking to Score, we're talking to a couple of other people. We'll be happy to roll that out to other teams.
Okay, so moving forward, we have the third in the trilogy, Grail, right? So you guys put together a basically is it Aurier? Like Oreo, or is it Aurier? Did I say your name properly?
Oh, this is, I mean, Irfan, Oria, yeah. Like, it's kind
Aurier.
of what you like, yeah.
And so Aurier, you guys are working on basically a version of it's like an inference verification mechanism,
Yes.
but it works on hashes of inferences from particular prompts, or it's like some form of basically commit reveals. No, it's a commit reveal. It's like a verification method. What is it? Commitment, a hash, right?
Yeah.
Over the inference, and so this allows you to basically like pay miners in inferences per second over top of them all, correct?
Yes, exactly.
And that's the basis of doing post training, because you need to have like copious amounts of inferences, which you then combine. You compute the verifiable reward on them. You take a GRPO average, and you then use that as the reinforcement learning loss to update the model parameters, and then you feed it back to those same workers. Correct?
Yeah, exactly. So we get those from the inference nodes or inference miners, and then actually, like, we are working on some variants of GRPO, so it's not gonna be exactly GRPO. So we're gonna do some innovation there as well. But that's about correct.
And Oria, what's your background? Just out of curiosity, like how did you come to this project?
Yeah, so my background, I've been like doing AI research for 9 years. I've been doing engineering for 5 years. I did actually my master's in Richard Sutton's lab, and actually collaborated with Google DeepMind a couple of times on some papers. Yeah. So that's my background. But like my most part of the focus in the past 4 to 5 years was reinforcement learning. And in the past 3 years, like mostly post-training and working on coding kind of benchmarks.
What are these innovations that you guys are like pushing towards on Grail? Like how are you? And by the way, is it up right now? Is Grail making inferences? Like how far are we away from a mainnet on Grail? And like tell me more about like what's going to make it unique and really, glasses out of the water. Like what size models we're going to be working with? Like how are we going to do that like data transfer?
Oh, that's a really good question. So I think right now we are actually working on a small models to kind of do our testing and everything. I think the inference kind of at least like the test and dev version is almost finished. Like it's gonna be like, tried out in a few days. But in deploying it out, I'm not sure. I actually need to talk with Sam and a couple of like other people. But we're gonna try to do that as soon as possible. And for the innovation part, in terms of like the reinforcement learning part, I'm thinking about a couple of like algorithms that I can use to make the whole thing like more sample efficient and more stable over time. Because when one problem that comes up, when we are training like reinforcement learning algorithms in this regime, is that there's actually something called off policy problem. That's like, if we kind of want to kind of simplify it a little bit, what happens is that a lot of times when the inference nodes sends us their prediction, or like the tokens they're generated, they're gonna be pretty outdated from the model that we are actually using, and that makes the training pretty destabilized. I mean, the training can kind of crash, it can kind of go in different ways. Like, to properly kind of exploit that knowledge and actually make something that works and be sample efficient, I mean, like, uses less data and it can be trained faster, it's going to be our main focus.
So the off policy problem here is this is important, because in order to verify the inferences came from the correct model, you need to have that state on the validators, and then when you do an update, you have to shuttle that back to the miners. So how are you thinking about like that problem? Like how to like overcome the just like the large web distance between the nodes and the bandwidth requirements here?
Oh, that's actually a really good thing that you mentioned. So I mean, the off policy problem, it can go a little bit far, but like when I mentioned that, I meant that, for example, like they are generated based on the correct model, but they're outdated because, for example, the model that we sent them for for like 6 windows before, or another way to think about it is like for like 20 minutes before that model got updated now, so it's kind of different. But in terms of like verifying like whether that the inference is coming from the right model, we actually developed some algorithms that properly check that by I mean, I can go to like much more detail if you want, like about those algorithms. Do you want me to do so?
Yeah, let's get deep.
Yeah, so I mean, like in simple terms, what we can do is that we can get the activations of the neural networks, right? Like LLMs that kind of make the predictions on the inference side, and they're gonna send us a compact representation of those activations. And in the validation side, we can, the miners are gonna send that to us. And the validation side, we can, do the same predictions and predict whether predict or not predict, like compare those activations with the activations that we have, and see whether those kind of like those kind of like rollouts or like tokens that has been generated are generated by the right model. Actually, like Prime Intellect 2 paper uses an algorithm to do this verification called top lock, right? Like we discussed it a little bit. And in our case, we are kind of using an algorithm is more efficient in terms of like memory that can do it like with about like 4 bytes of memory per each of the activations, instead of using most of the activation or top K part of the activation like top lock.
So where does this come into play? Like, well, I guess there's a lot of questions here. Like, nothing really is it's out in the wild. You're new to BitTensor, Aurea, which means you're going to get to learn the fun way that dealing with miners is very difficult, and things that are seem like a good idea when abstract on paper are not so great in reality. But the truth is that the faster we move, the faster we learn. And so it's exciting. Like we're going to be generating a lot of inferences, and hopefully we can pre-train the models that come straight off the Templar. Shifting focus a little bit, like not only did we come up with Amir came up with a fantastic algorithm, state of the art, but we also have, I think, the largest decentralized training run ever. Sort of like a secret in the community. People don't know about things. But it's a massive deal. And we're training a 70 billion parameter model, thought like otherwise impossible. So Adam, like you're kind of head on that. Like, can you tell us about the state of the network on Templar right now? Like what is the best what's our model looking like right now? Like what new techniques are we using? Perhaps Distributed can answer if Adam's done online. But like, tell us about this latest run. Like, what are we looking at when we go to Templar.ai/dashboard?
Yeah, so I guess for the 70B run, it's like a real testament of the Sparse Loco as well, to see how well it scales. We have some problems with like the scaling if for like checkpointing that the miners is complaining a lot about right now. So that's what we're trying to work on. So it's been quite a bit of challenge to like scale to this size, because we needed to make a lot of our code distributed in a way that it wasn't before, because we had before we could fit like the model on one GPU and do like DDP, but now we have to shard the model across multiple GPUs, and there are still parts of the code like the checkpointing that needs to be properly implemented for like this distributed setting. But we have seen that with Sparse Loco the throughput is really good. We get we get good results. We want to scale. We want to increase the top K, because we've seen that also that have shown that we get even better loss curves. So yeah, it's a bit of optimization works right now to get like 7 to be stabilized, and then we will go for a longer run. Yeah, test in production.
There's simply no other way when you're dealing with incentives. We learned this the long way, you might say. People also often like criticize Bitstamp. They're like, "Oh, you release like you know incomplete tech," and I'm like, "What? You don't release any tech." And I want to see when you guys deal with miners trying to destroy what you're building. And like the thing is that I think we've like built. Yeah, well, you actually can't test privately either, Ultraverse, and the reason you can't do that is because the incentives are actually the product, and you cannot simulate it. And the reason you can't, I mean, you can make your mechanism stronger, but you can't simulate the intelligence of the swarm that's going to try to break you apart. So, like, one of the things I think is so incredible about the training runs that that you guys are doing on Templar is that you haven't done just one or two or three or four. You've done what, maybe 40 runs at different sizes, maybe 50 runs, maybe 100 runs, and every single time learning something new about the way in which the mechanism like plays out on the web. So like, how is this latest run doing? Like, Adam, like it's like okay, right? So we're looking at it. We're going, okay, maybe we've got to fix some things, and we're probably going to restart the run. Correct, Adam?
Yeah, so there are some issues with checkpointing, which is we want to have so everyone can be in sync and you can start join a run later and catch up. But I think the like initial 70B runs looks very promising. It's just about to get like the real metrics. We need to have let it run for a bit longer, but we want to stabilize it a bit more first, and we also have done some hyperparameter testing in production. Yeah, but I think we got the hyperparameters we want to run with now. It's just about finalizing the last part to make it stable with the checkpointings, and so everyone can join mid-run or catch up, or so everyone can be in sync basically. So that's the current state of it, but it looks very promising, and we are getting loss curves that we expect at this size. Yeah.
So where does the next 10x in terms of scale come from, and also from optimization in the network? Or is it like we've already optimized and like everything, we just need to run a bunch of experiments now? Is it like, where are we in Templar? Yeah, when 450B. 70 billion is feeling really small right now, actually.
Yeah, I think we have the researchers working on the behind the scenes. So we have some ideas, but I'm not sure if we're ready to share them or not. So, but yeah, we have some ideas on how to scale it even further. Yeah.
In terms of tokens per second, like what do we add, and like what does this mean in terms of like reaching 1 trillion tokens or 100 trillion tokens?
So I think currently with the base miner, it started out at like 5k tokens per sec or something like that, and now we are at like 10k or something like that, and we still have some optimizations to do for sure. We have a great guy helping us out with that as well, that is an expert with making this run as efficient as possible. So right now we're running with FSDP, but we're working on getting like tensor parallelism working, and also the potential to use multiple nodes within one miner, for example. So yeah, we are working on increasing the throughput there, and generally just stabilizing the validator mostly. The miner is pretty stable right now, I would say, but the validator and checkpoint is what I will be focusing on this weekend. Yeah.
Blame the miners. Blame the miners.
Yeah, blame.
Samuel, yeah, I mean, like we're over the time for the call. It's only an hour. I know it's not enough for 3 subnets. Like hopefully next time we come up on stage it'll be like one per subnet. But right now, Basilica and Grail are still kind of in like this, they're like fostering, like incubating them. Uh, which one are you the most excited about?
I don't know.
Which one are you most?
It's like
which one are you spending your time on? Which of your children you like the most?
Fuck Templar, man. No, jokes. Templar is pretty much self-sufficient right now, and sadly, I don't contribute barely any code to that anymore. So most of my time now is spent on Grail and Basilica a lot, because what no one warned you about is infrastructure subnets are just a lot of code, like crazy amount of code. But we have me, Everin, and Henil, who just joined us, is not on stage working on that. And the Grail work, we're about to kick that into hyperdrive over the weekend and next week.
Amazing. Should we open up the floor here for people to ask questions? Somebody wants to come on stage. Do we want to let that happen? It can go many different ways.
Yeah. Oh, no, they left. I'd love to have people on stage.
Let's open it up to questions for people in the crowd, minors, if they want to air their grievances towards Samuel. Now's your time.
I might burn 100% though, but let's see.
No? He was around. That's not a topic, Tiago. Dr. P wants to come up. We're gonna let this happen. Too late.
Hello, am I audible? Hello.
Yes, you are.
Can
You
hear
are.
me?
Mhm,
Awesome.
mhm.
Yeah, just wanted to ask if there are any plans to launch a simple CLI that can crowdsource compute from basically all the devices that can contribute to the training of Templar models or inference, but training specifically.
It should be possible. It should be possible. And you could even in principle do that today, but we just need to get validation, because we have a deploy. So there's a Basilica deploy option that lets you take a container and deploy it. So technically, we see a world where one of the things we're looking at is BitTest is really hard. Yeah. And one thing I love about Ridges is that they've been able to constrain their problem, to constrain the incentive problem, and extract all the blockchain and BitTensor like lovely bullshit away. So this opens up the floor to more people being able to join it, because right now, like, even one problem we have is that we get like amazing researchers, amazing engineers, but they take at least a month to be productive just off the BitTensor stuff. And so what happens is that you get your subnets don't grow, because most of your miners that learn all the tricks and bells and whistles, they're not necessarily the top. They're very smart people, but they're not necessarily the top of their field. But the problem is that when you get to an advanced stage, a lot of people will give up before they actually get to, okay, how do I optimize this incentive mechanism? So it's definitely one of the things we're thinking about is how do we, for Templar, how can you spin up a base miner but still be competitive? Like, how can you spin up a miner? How can we redesign the incentive mechanism in a way that you don't have to deal with blockchain, just improve the training of it? And the ideas around it, like, take for example, we can change the model to, I'm sure the model miners will hate this, but we probably will do this soon. We change the model to, okay, give us the best base miner, and we just keep running training runs on either Liam or Basilica. So that way it inverts the problem that, okay, we're going to keep training. And it also changes the dynamic of it, because again, it's hard to make that a permissionless run, or it's not really a permissionless run, because you have those base miners and you have another competition for people to create base miners. But we're definitely thinking around permutations of that too. Yeah, that would definitely be interesting. So
Right. Yeah, I think zooming out, the biggest differentiator after the right incentive mechanism slash algorithms are set for training models at scale would be the bitter lesson of um, just taking the number of flops available to infinity, right? And so whoever makes it super easy for anyone to contribute, um, their compute, um, their flops in whatever way possible, I think that would be a big differentiator, and we should pay attention to it. Um, Baliska is supposed to be the store for compute, right? Sam?
yes. It is it's meant to be stuff for compute. But what you said is it's also very important, and also
Mhm.
stuff like we're going to be working over the 3 months is how to make flops better. And that's all I can say about it. It's like it's going to be a very massive breakthrough because you say like we had scaling we because again
So
compute cost.
yes, I think it's very easy to get lost in the weeds of making each flop more efficient. But then if you look at the big tech and OpenAI and all of them, they're just trying to raise like an insane amount of capital, like trillions of dollars, and throw at these unoptimized architectures to get even like a bit of fucking of a performance out. So I think we have to play both games. We have to scale the capital and we have to like optimize the architectures. And it's very easy for a nerd-type mind to just get lost in optimizing the algo.
Yeah. So for us, we're not. So there's different things. There's different kind of optimization, but we're not touching that yet. So if you look at things like MOEs and multi-latent attention, they directly go towards like an algorithmic a change of architecture that makes it cheaper to serve stuff. That's why MLA is very good. OpenAI's GPT or OSS is rumored to be maybe not as efficient, but it's very cheap to serve. So there's that bit of stuff. But what we're working on is a bit adjacent to saying, okay, how do we realize more flops of cheap hardware? So it's still the same theme, but I think it's a radical approach towards achieving that, which would allow us and allow any company on BitTensor to serve stuff cheaper. Although we'll probably have a little bit of a head start on that.
Makes sense. As an inspiration, something that we did with Subnet 24 and Focus was that we created an independent marketplace where people can submit Focus videos, and then 256 Subnet 24 miners can just come and buy the marketplace videos, which allows you to just expand the marketplace nodes to basically infinity. And then the bottleneck is just like the buying speed of the miners of Subnet 24 and the emissions available. And so I feel like I don't know how you will handle the 256 UIDs versus just having room for the marketplace slash the compute nodes to grow to infinity. And what the state of the art thinking is. But yeah, just an inspiration.
Definitely. Would definitely love to share notes. For us, at least on this level, we don't actually need that many UID slots because we are kind of. So one of the open problems with the local is that how many accelerators can actually be useful to your trainer run. Yes. So and the local it maxes out at like 16 to 16, another 16, 18 bits. So another form of research we're going to be doing is how can we increase that? So until we can increase that, what we do, we don't actually need more than 40, 50, like 40 miners active because not all of them can contribute to the model anyway. So for us, it's not that problem. But for the compute bits, we're borrowing very heavily from the work Liam has done. In that it doesn't matter, one UID can serve 50 million GPUs. So the problem becomes maybe your verification time and also the price of The price of tau subsumes all.
Makes sense. Makes sense. Also, a lot of marketing needs to happen around making like Tau the Bitcoin of AI and instilling it into the masses. Because if that
That's
happens, then people forget the current price of Tau and they're like ideologically aligned and everyone's like, okay, let's vote Tau right now.
yeah, but I think this is a multifaceted problem. I think we need to do good work. Yeah. And I think detail, like, so there's a lot of pain in the ecosystem. Yeah. Like I'm bleeding every day. Like I wake up every day and send Jake some hate mail. But if you look at it from a fundamental, I don't think for the outputs of subnets, I don't think it's ever been greater. I mean, compared to the kind of work we did in the root network, like all subnets are punching far, far, far higher. But the thing is, we need to keep punching until we can hit escape velocity. Who does it? Is it Chutes? Is it Ridges? But eventually, we can already see signs. Like I saw something I was very impressed with. On Twitter, they were like, "What is Chutes bit tensor? This is how we win." But it's just that, like it's just that there's nothing Cos could have done to stop people from aping so much. And when people ape so much without understanding the underlying mechanisms, the tech is never going to be good. So as builders, we need to keep pushing through that and also be sympathetic to holders that, they are very simple people. Like, make me money, I will love you. Most of them. But when they ape when a lot of people aped at when sum of subs was 2.2, and they're surprised they're surprised that things have come down now. And for us builders, the first thing is, why do you do that, you idiot? It doesn't help things. We need to be sympathetic towards holders too, because quite frankly, we exist because of them.
Yeah, I think on a tangent, one of the high leverage KPIs to measure is like amongst all the subnets or amongst the BitTensor affiliated or core team, like right now in this moment, how many background coding agents you have running that are just consistently churning code out? Like how many background coding agents does Templar have right now while you guys are on this while you guys are on this call that are just churning code out on GitHub?
His name is Adam W.
He's on the call muted running like fucking 20 codex CLS.
I have two agents. It's called Evan and Adam W, and they're just churning.
But that's the bottleneck now, right? Like coding is almost solved. We're just showing like an inference bank of compute just deployed, just churning open source code out all the time. And OpenAI and like Google has that internally deployed right now. And they have reached an escape velocity. So we got to beat them. Like it's going to be a hard game if we don't have like background coding agents just deployed working on the mission critical repositories.
Yeah, definitely. It's a problem. You can't solve everything. So unless people want me to get another subnet, then I would happily indulge. But we leave the agent stuff to. I'm bullish on background. What the fuck is Kara saying? Hold on. Cool. Yeah. Okay. Yeah. So we'll leave that to solve it. But yeah, that's so. There was a time when using AI was a dirty word. Now I wouldn't hire anyone that doesn't use AI because it shows like don't get it twisted. AI can produce a lot of slop code, but for me personally, I think there's a lot of hubris. When because people say, oh, AI produces slop. I'm like, bro, you took a week to send me the same slop. So it's not like it's not Deus ex machina. It's more of looking out for the hybrid, the way man and machine work together. And use AI, or I just want to work with you.
Cool, guys. That's pretty much it from my side. Awesome work, Sam and the I think we have met in Toronto, if I'm correct.
I've never been to Toronto in my life, and I never plan on setting foot in Canada.
Montreal is the place you should come to. Montreal is the place you should come to. Yeah, and don't come here after October, but before that, it's the best place in the whole of North America.
Montreal is amazing. That's a great note to end this on. Some amazing people in Montreal, by the way, like the authors of your paper, Sparse Loco, distributed. So I think there's definitely a reason for you to go. Thanks to everyone that came to the call. Scintillating, as usual. Samuel, Adam, the rest. Thanks, everyone, and have a good night.